Tiffany glanced down at the ring on her finger. It had a dull shine. It had never rust while she wore it, the blacksmith had told her, because of the oils in her skin. He'd even taken the time to cut the little snowflakes in it with a tiny chisel. "It's just a ring I had made out of a nail," she said. "Iron enough to make a ring," said Granny, and Tiffany stopped dead. Hi, Year 7. So today we're going to be looking at some more reactions, and we're going to be looking at the reactions of metal with oxygen. Can you think of any? Yes, that's right. Bit of a hint in the story I was telling, wasn't it? Iron reacts with oxygen and makes rust. Does anyone know what the real name for rust is? Iron and oxygen might react together to make... Well done! Iron oxide. Iron oxide is the real name for rust. And we're going to do some experiments to see what happens when metals react with oxygen. Now, obviously, with iron, it makes rust. And this is a special type of reaction called an oxidation reaction. Oxidation means adding oxygen. So in this case, we're going to add oxygen to metals. You are going to need some iron nails, nail enough to make a ring. So we're going to do 3 iron nails, and we're going to see what nails need to rust. Okay, and then I'm going to show you a little bit of a quicker way to oxidize metals, which is through burning them. I do like burning stuff, so I'm really happy about that. Okay, so let's see what we'll need. Okay then, Year 7. So what I've got is I've got 3 containers. It really doesn't matter if the containers are the same or not, so long as you've got 3 containers. Now we're going to think about what makes a nail rust. I heard oxygen. Well done, well remembered. Anything else? Water. Excellent. So we might need air with oxygen in, and we might need some water. So what have I got here? First of all, I have got a perfectly clean and dry, because I've just cleaned and dried it, glass. And into this, I'm going to add 1 iron nail. Okay, so if all we need is oxygen to make the nail rust, then we'll get oxygen. This nail should rust. Into my second glass, I have got some fairly cool boiled water. Okay, so I do this because water has got a lot of minerals in it when it comes out the tap. If you boil it, quite a lot of those minerals come out of the water. So I've got some, it's not fully deionized. If you've got some purified water, maybe ironing water, or for a car or something like that, that would be better. But cool boiled water is fine for most of us. So if it's just water that makes a nail rust, yeah, this nail should go rusty. I'm going to pop it into the water. It's completely covered by water. And to make sure no air will get in, I'm going to pop a little bit of oil over the top. This is just olive oil, so cooking oil. Any oil will do, sunflower oil, olive oil. This oil layer will stop any oxygen from getting to the nail. And if the oxygen gets to the nail, then it's not a proper test, is it? Because we've got water and oxygen, and all we want is water. For our last one, I've got water, and the nail will also be exposed to the air if I stand it up. I'm going to have to fiddle with it a little bit. There we go. Let's lean it against the side. So there we go. It's a nice wet nail, and it's exposed to air as well. Now I want you to make a prediction. Which one do you think will rust first? Which one's going to be the most rusty? Which one's going to be the least rusty? Because we're going to look at this in our final lesson. This one, unfortunately, isn't going to happen overnight. We're going to have to wait and see. So that's the first experiment. The second experiment you probably won't be able to do at home, but I'd like to show you anyway, so come with me. Okay, so the first thing I'm going to burn is some steel wool, which is mostly iron, and we're going to see what happens to this silvery steel as it burns. So let's get a bit of fire. You'll notice I'm not holding this with my hands, I'm using tweezers, and let's burn it. Okay, it's on fire, let's let it burn out. And let's take a good look at it. So where it was silver, you can see the bit that hasn't burnt here, it's now turned black. Okay, was silver, has now turned black. Colour change, if you remember, is a sign that a chemical reaction has happened. So we've had a chemical reaction, we've reacted the iron with the oxygen in the air and made one type of iron oxide. There are two types. And they differ slightly in chemical formula, but you'd know the difference by colour. Second one I'm going to do is magnesium. I'm going to burn the magnesium. This is going to catch on fire. Now you should be okay to watch it through the screen. When we do this normally, we tell you do not look directly at it because it can temporarily blind you and it can cause eye damage. You should be fine watching it through the screen though. If you don't want to watch it, you can pause the video or you can look away. I will tell you when it's safe to look. So here we go. Let's move my hand a bit further back. Catch the magnesium on fire. It has oxidised slightly, so it's going to be a little bit difficult to catch on fire. Nearly. There we go. So can you see that lovely blinding light of magnesium? And if the camera comes a little bit closer, please, you can see that the magnesium was a dull grey colour as it had reacted with the oxygen in the air. I should have cleaned it really. But the white magnesium oxide, so if we look on the surface there, the white magnesium oxide is what has reacted, a colour change. We've got a new chemical, and I'm not going to touch that because it's actually quite nasty to touch. It will react with my skin and do nasty things to it. It is an irritant. Okay, so that's it. Nice short video from me today. The main things I want you to learn: the word oxidation, which means adding oxygen, and that metals undergo oxidation to make a metal oxide. So for example, one of these nails will hopefully be covered in iron oxide next time we look at them. Our magnesium reacted with oxygen as well to make magnesium oxide, and any metal you can think of. Yep, aluminium oxide, that is a thing as well. Yes, vanadium oxide is a thing. Gold oxide, that's a good one. Gold doesn't really react, so we don't get much gold oxide. But even copper, which is pretty much as unreactive as you get, will react with oxygen to make copper oxide, which is known as verdigris. And you can see that on roofs that used to be copper and are now a lovely sort of bluey green colour. Anyway, that's all from me. There is a very small worksheet to do, and there is hopefully this experiment to set up because I'd love to see the results of it. Okay, take care, Year 7. See you next time.